so what you got in front of you there is your final assignment on Newton's second law. Okay, so there's a lot of different types of questions on that sheet, but we have done many examples of each one, right? Some of them are very simple. Some of them are static condition questions. Some of them are vectored questions. Some of them are inclined planes. Okay, there's a little bit of everything. There's a system question in there as well. Okay, so just kind of be aware. Make sure you look at the point values to get an idea of just how much work is involved in each question, because it gives you a pretty good idea. Like case in point, question number 1, which is only out of 2 marks, because it's ridiculously easy. Okay, givens and math, and that's it. Okay, so I'll just kind of go through these here, and I'll talk about a few of them just to give you explanation. You might want to write a few of the things I say down on your paper just so you have them for later. Okay, question number 1, don't overthink it. And also, for all of the questions, pay attention to vectors. Okay, make sure your answers have a vector on them. Okay, for question number 2, again, don't overthink that one. You've got some velocity and time information there, okay, and you need to find the average net force. Again, it's not a terribly complex question, so don't overthink it. Okay, question number 3 is telling you that you have a force vector, 720 newtons, 38 degrees north of east. All that question wants you to do is find the x and y components of that vector, okay, or of that force. So it's very much like what you would have done on your vector assignment. You're just finding x and y on number 3. Okay? Should x and y have their own vectors? I would say so. Okay? All right, for question number 4, question number 4 throws people, so really pay attention to this one. In question number 4, there are 3 parts. Okay? This is part A, this is part B, and this is part C. Right? These are the free body diagrams for those parts. So you don't need to draw free body diagrams for question number 4. Okay? What they want is the accelerations in each situation. So what's the acceleration if these 2 forces are acting on the 5 kilogram mass? Okay? In part B, what's the acceleration now that the forces have changed and one of them is angled and one is horizontal? And in part C, well, they're collinear and both going the same direction. What's the acceleration? All right, so you do have to do a bit of vector stuff in question number 4. Okay? None of it is like super complex, but you do have to do a bit of it. Okay? But it's 3 separate parts. And is acceleration a vector quantity? Yes. So make sure your acceleration has a vector on it for that question, as that's a very common mistake that I see on that question. Okay, question number 5. Also one that throws people, and it's mostly because they don't read it through very carefully. So we have this 36.5 kilogram sphere acted upon by 2 forces. One of the forces is 113 newtons directed along the positive x-axis, and then there's a second unknown force. Okay, the magnitude and direction of this what must the magnitude and the direction of the second force be such that the sphere experiences an acceleration of 3.96 meters per second squared, 21 degrees above the x-axis? So they're giving you the mass and the acceleration and one of the 2 forces. They're asking you to find the one they didn't give you, the unknown force. So you're kind of working backwards here a little bit to find one of the 2 forces that adds up to the vector sum of all forces. Here's the big hint for that. It's not vertical. Okay? The 113, that's directed along the x-axis, so it is a horizontal force. The unknown force is not vertical. Okay? I have people just assume, oh, well, I'll just draw it up. This is an x and a y, and I'm done. It's not. Okay? That second force is an angled force. Okay? All right, number 6. So we have this highly impractically designed spacecraft with 4 engines on it. Okay? Now, The spacecraft, we know its mass, 4,160 kilograms. We know its initial velocity, okay? That initial velocity is going to the right, okay? So this way. The ship has 4 engines, each of which can provide 68,000 newtons of force. All right, here's the thing you need to know about this ship. You can only use 1 engine at a time, okay? So what we want to do is not go this way anymore, so we have to stop, and then we want to go this way at twice the original velocity. Right? So you have to fire 2 engines to make that happen. You have to decide which 2 engines need to be fired and for how long. Here's the other thing about the engines. Not only can you only fire 1 at a time, but they're either on or off. There's no throttle. When they're on, they exert 68,000 newtons worth of force. When they're off, nothing. They're either on or off. Because if there was a throttle, this question would actually be way harder. Okay, so they're either on or off for the sake of simplicity. Okay, so which 2 engines do you need to fire, and how long in seconds do you need to fire each one? Okay, and there are 2 steps to this question: stopping and then accelerating in the second direction. Okay, 7 and 8, static condition questions. We have done ones exactly like both of these in class. So if you're really stuck and you wrote down all the examples we've done, you'll find these questions somewhere. Okay, I would advise that for question number 7, you watch your significant digits carefully. Okay, question number 9. We have a box, or the suitcase, being pulled at a constant speed, okay, pulling on a handle that makes an angle, an unknown angle, with the horizontal. The frictional force on the suitcase is 27 newtons, and Mia exerts 43 newtons worth of force on the handle. So you're looking for 2 things. In part A, what angle is she pulling it at? And what is the normal force acting on the suitcase? So I would say to you that the free body diagram for this question is important. Okay? There is more than these 2 forces. Okay? Remember that you're looking for this force, but there are other forces, okay, vertical forces, that are involved here, right? But remember, the suitcase is moving horizontally. The suitcase is not moving vertically. Okay, everyone with me there? And then 10 and 11 are both inclined plane questions. Okay, so spoiler alert, 9 is not an inclined plane, because I sometimes have people solve that as an inclined plane. It's not. Okay, but 10 and 11 are. And watch for that trick I told you gets played on you sometimes. Okay, with inclined plane questions, you are given the weight of the boxes on those 2 questions, not the masses. Okay, and you'll probably need the masses for those. Okay. All right. Questions from you guys?
On question 2, is 9, 11 just like the type of Porsche?
Yes. It's the type of Porsche. It is not a measured value. It is a model number. Okay. Any other questions, guys? All right. You have the whole class to work on. Okay. I'm going to make it due after Easter. I'll put a date up here in a little bit. Okay? And not the Monday after Easter. I'm not that much of a jerk. But we'll see.